All right, welcome back again, students. So in our previous episode, we looked at equality of matrix. Now on this episode, we are going to look at the determinant of 2 by 2 matrix and the determinant of 3 by 3 matrix. That's our main objective on this particular episode. So let's go on. Already, let's start with the determinant of 2 by 2 matrix. Right? Already we know our 2 by 2 matrix. Example, if I have M, right, is given by A, B, C, D. This is a 2 by 2 matrix, okay? Now, if M is equal to A, B, C, D, then, now, determinant of M actually, the determinant of M is written as, det M or this. So when you see det of M, it means determinant of M. Now when you also see this, it means determinant of M. This doesn't mean magnitude, okay? In matrix, this one means what? Determinant. Now, and then determinant of M, if I want to find determinant, right, is given by, because of this bar, we also put the element in this bar like that, right? And then when you have a particular matrix, this diagonal from here, from the top left up to the cross right down, this is called the leading diagonal. In some books you see the principal diagonal, some you see the main diagonal. That is the main diagonal or the leading diagonal, right? Now determinant of M, that is that of M, or you can also say this, is given by the leading multiplication of the leading diagonal, that is A times D minus the multiplication of the other diagonal, B times what? C. So it's going to be AD minus what? BC. It's that simple. Okay? It's that simple. So for instance, if I have a matrix M equals 2, 3, 4, 5, then the determinant of M, right, is given by 2, 3, 4, 5. So the leading diagonal is this, right? So 2 times 5, that's going to be 10. Let me write. So 2 times 5 minus what? 3 times what? 4. That's going to be 12. So at the end, I have 2 times 5 is going to be 10 minus 12. So that's going to be negative 2. That's going to be my determinant, okay? So the determinant of this one is minus 2, right? Now, sorry. Alright, now let's look at how to, this is how we find the determinant of 2 by 2 matrix. Now let's look at how to find the determinant of 3 by 3 matrix, okay? So determinant of 3 by 3 matrix is actually given as, now if I have A equals, I have A, B, C, D, E, F, G, H, I. This is quite a big, a complex process, but the determinant of 3 by 3 matrix is given by the determinant of the 2 by 2 matrix found in this 3 by 3 matrix multiplied by what we call the cofactor, okay? Multiplied by the cofactor. So for instance, so and before we do that, for 3 by 3 matrix, invisibly every component you see here has a point, has a sign, right? It starts with a positive. Now, for you to understand, just start the first one, start with a positive. You know, like poles attract, like poles repels, like poles attract. So since A is positive, the second one will be negative. Since this is negative, this one will be positive. Of course, this is positive, so this will be negative. Since this is negative, here will be positive. Since this is positive, here is what? Negative. Negative here will be what? Positive. Since this is positive, here will be negative, and negative here will be what? Positive. So these ones have invisible, what do you call it? Signs with them, which you need to know, because you apply it when you are solving for the determinant because of the cofactor. So if you look at that, if you look at this, for instance, look at the crosswise like this, all of them are positive. The negative are what? In between like that. Okay. So the first thing is to get this one in your mind. The first value here is positive. This is negative, positive, negative, positive, negative. It's like that, right? And they will not tell you this, so you have to know. You have to know before you solve it. Okay. So if I have, let me write it again because this one has. So I have A, B, C, D, E, F, G, H, I. So if I want to find the determinant of A, the determinant of A is given by, look at it. If I take a cofactor, if I take A, right, the very factor that I take, I freeze each row and I freeze its column. So if I take A, I freeze the row of A and I freeze the column of A. What is left? The 2 by 2 matrix that is left is what? This. So I'm left with what? E, F, H, and then what? I. So when I take a cofactor, I freeze each row and each column, and then the matrix left, I use the cofactor to multiply the determinant of that matrix left. Okay. So here, if I take A, I freeze the column of A and freeze the row. I'm left with this. Then I write it. Are you getting that? Now, if I'm going to the second one, remember the value here is negative. I told you they will not tell you, but here is negative. So negative B. Look at what happens. I freeze the row of that B and freeze the column of that B. If I freeze the row and column, I'm left with this 2 and this 2. Then I write it. So D, F, G, and I. You see that if I freeze here and I freeze here like this, I'm left with D, G, E, and are you getting that? And then I take the third one, that is C. So if I take C, I freeze each row and each column. I'm left with D, E, G, and then what? H. You get that? So this is how we find it. But this is the normal 2 by 2 determinant of 2 by 2, you know. So this is going to be A multiplying, finding the determinant here, E times I minus what? HF, right? Then minus B into bracket. This is going to be what? DI minus what? JF. Then minus C. This is going to be what? C multiplying. This is going to be DH minus what? GE. Are you okay? Right? GE. Yes, this is going to be positive C, sorry, because the value here is positive. It's not going to be negative. Do you see that? As we explained there, right? So, for example, if I tell you to find the determinant, if I have a matrix M, and I tell you, let's say 2, 1, 3, 2, 3, 4, 5, 4, 2. If I tell you to find the determinant of this particular matrix, then the determinant is given by, when I take 2, now, you can choose the row or column. So if you choose to this column after this, when you choose this, you freeze each row and each column, then the one you write, right? When you choose this one too, you freeze each row and each column. But I always advise go this way. That is the row method, okay? Alright, so finding the determinant of this one, we all know the first cofactor 2, we freeze each row and we freeze each column. So we are left with what? When we freeze this and this, we are left with 3, 4, and then 4, 2, right? You know this minus 1, right? Remember? The sign is negative. So we freeze this side and this side. When we freeze this side and then this side, we are left with what? 2, 5, 4, and then 2. Is that not so? And we take the first one, that will be positive. So positive 3. We freeze each row and column. We are left with 2, 3, 5, and then what? 4. Then we solve this one. So these 2 into bracket, we find the determinant of this by 2 by 2 method. So 3, 2 is going to be 6, minus 4, 4 is going to be 16, minus 2, 2 is going to be 4, 5, 4 is going to be 20, and then plus 3 bracket of 2 times 4 is going to be 8, and then 5 times 3 is going to be what? 15. So at the end, I have 2 bracket of this minus this is going to give me negative 10, minus 4 minus 20 is going to give me minus 16, and then plus 3, 8 minus 15 is going to give me 7, right? So at the end, I have minus 20 plus 16 plus 21, right? Okay, so You all know minus 20 plus 15 is going to give me minus 4, and minus 4 plus 21 is going to give me 17, I guess, right? So the final answer is going to give me 17. Okay. All right. So this is where we'll draw the curtain on how to find determinant of matrix. On the next episode, we will look at how to find the inverse of a matrix. So until we meet next time, I'll say goodbye.